Okay, so let's see. I'm hoping this is working, Tony. Okay, so I need to, let me go over, I have lots of, I'm just going to go over here. Oh, no, I had you on there. Anyway, we're going to go to PLC High School and let's add a page and let's call this Tony. I don't have my iPad with me. So this is 10.1 and 10.4. Okay, so that 10 or 10.3, it's not 10 point. I don't think I got any of this right. It was 10.3, number one. So let me fix that. Um, no, 10.3, number one. And then I think you said 10.4, number 13. So 10.3, and this isn't going real well. I may have to just wait till I get home. 10.3, and this is question one. And it tells me to determine which of the following expressions are meaningful. Okay, and of course you looked at these in the back of the book to get your answers on there, and you found that A dot B dot C was not meaningful. B, you found that A dot B times C was meaningful. Okay. C, you found that the length of A times B dot C was meaningful. And then D, you found that A dot B plus C was meaningful. And then finally, oh, well, we do have an E and an F also. We found that E, A dot B plus C was not meaningful. And F, we had A, length of A times B plus C, and that was not meaningful. Okay, so yeah, the back of the book can tell us all that, but let's talk about where all this comes from. Over on page 551, we have a host of properties of the dot product. And it states if A, B, and C are vectors in V3 and C, the italicized C, is a scalar, then the following properties happen. And we had number one, we had A dot A is actually going to equal the length of A squared. Two, we had A dot B is the same thing as B dot A. The dot product between A and B is the same as the dot product between B and A. Three, we had A times the dot product of B plus C, and here C is a vector, equals A, the dot product of A and B, plus the dot product of A and C. And four, we had, now this C is my little italicized scalar. That's just some number. Dot product with B is actually going to be, we can take that scalar out. And we can multiply that times the dot product of A and B. And then that also equals, and it's important to know that this is the same as the dot product of A with C times B, where that's a scalar. You might make a little note, is a scalar. That just means it's a constant, like 3. Okay, it's just some number. And then we had 5, of course, that said 0 times the dot product with the dot product of A equals 0, of course. Now, here's how these things are meaningful. They're not meaningful. If you can relate them back to one of these 5 properties on page 551. That's a lot of fives. Just now noticed that. Then they're going to be meaningful. Okay, such as in A, you don't have anything that talks about A dot B. You don't talk about the dot product of A and B combined with the dot product of C. We don't see that happening over here. We don't have three dot products going on. So it's meaningless. It doesn't do anything for us. B, we have a dot product, and then we're multiplying it times C, like a scalar. Well, if I look hard enough, it looks kind of like number 4. Okay, so this is like number 4 right here, because I can say down here on B, I have the dot product of A and B then times C. So I have the dot product of A and B then times C. Okay, well, it looks like number 4 because that's that middle. Well, if C is a scalar in there, then C can go to the back also, correct? So this is really the same thing as C times the dot product of A and B, which of course is the same thing as C times A, the dot product of B. Okay? And that also equals A dot product of C times B. Okay? So that's why B is meaningful. If I look at C, all right, C took me a little bit. I'm going to come back to that one. Let's do D. And I'm writing with a little bitty stylus that came with my laptop. If I'm looking at D, D is meaningful. We can find D. You see D real well right there. It goes with number 3. Okay. So I know that A dot product of B plus C is actually going to equal A dot product B plus A dot product C. So that's why it's meaningful. And then finally, C is going to truth. C relates back to, in my opinion, C relates back to number 4. Because think about it. What is the length of A? That's what those bars A. It's actually asking you for the length of that vector, the magnitude of that vector. What happens? Well, not magnitude, but it's asking you for the length. Okay? What is a length? A length is just a number. It is a scalar, right? So it's like C. So we can say that since the length of A is a number slash scalar, this is the same as saying C, where C is a scalar, C dot times B dot C. Okay. You might make yourself a little note. This is a scalar. I didn't draw it real italicized. Okay, well, then that goes back to what? That's going to go back to number 4. I've got C, where C is a scalar, times the dot product of A and B. Okay, goes back to 4. Okay, which then will tell me, sorry, I know I'm not real good at running this one, which then that tells me this is really just, we have C, the scalar C times B dot product C. So that can equal, I need it to be smaller, CB or CA dot product, so that's going to be CB because we need to use the letters that we have. CB dot product of C, that's the scalar. I'm going to put the scalar in yellow. Okay, that's the scalar. That other C is not. Which equals, of course, my C, where that C is the scalar. B dot C, that's what you had, which equals B dot C, C. This is my scalar. This is my scalar. Okay? So it goes back to number 4. Okay, let's see if this works.